Welcome to the Algebra 2 cubic cube root review. Let's start off with 1 and 2. So it says label each parent function and give the domain and range. Alright, so this one is going to be a cubic function. The parent function is y equals x cubed. Domain and range is all real numbers. Number 2, this is going to be a cube root function. Cube root function is y equals the cube root of x, and domain and range is also all real numbers. Right, both of these functions are increasing. And they're increasing, they're inverses of each other, and they both have domain and range of all real numbers. Alright, then 3 through 7, you're just stating the transformations. So number 3, 5x cubed minus 4 has a vertical expansion by 5. It's going to have a shift down 4. Number 4, we have a negative out in front. That's a reflection over the x. Reflection over the x, or vertical reflection. And then x plus 4 is inside the parentheses cube, so we're going to go left 4. Number 5, we have the 1/5, so that's a vertical compression by a 5th. And then we're going to go up 1 because of the plus 1. Number 6, we have a 7 out in front. That's the a value, so that's a vertical expansion by 7. We have a shift right 6, since we have minus 6 on the inside, and then plus 2 on the outside means go up 2. For number 7, again, we have a negative out in front. That's going to tell us to reflect over the x. We have that vertical compression by a 1/3. And then that plus on the inside is telling us that the graph shifts left 9. Alright, so those are transformations. Now let's look at 8 through 12. This is writing the equation based off the transformation. So we also got to keep in mind this is a cube root function. Right, this is a cube root. Alright, so we got y equals, we have reflection over the x, so we need a negative out in front. We're going to go up 3, so we just need a 3 on the outside. And this is a cube root function, so cube root of x with a plus 3 at the end. Number 9, we're going to go left 6 down 8, so y equals the cube root of x. Alright, that's our function. Since we want to go left 6, we need a plus 6 on the inside. We want to go down 8, so minus 8 on the outside. For number 10, we have a vertical expansion by 5, and we're going right 1, so y equals the cube root. Oh wait, hold on. We need a 5 out in front. That's going to be the a value. Alright, so first we have the 5. Then we have the cube root of x. We're going to go right 1, so we need a minus 1 inside the cube root. Right, for number 11, we have reflection over the x, left 9, so y equals negative cube root x plus 9 on the inside, since we went left 9. And then 12, y equals compression by a 3/4 cube root of x, and then we're going up 12, so plus 12 on the outside. Alright, so let's go to the next page. Alright, number 13, 14, 15, this is on differences. So 5 to 8, 8 to 17, 17 to 32. Alright, so 5 to 8, we have to add 3. 8 to 17, we have to add 9. 17 to 32, we have to add, what would that be, 15. 32 to 53, add 21. Alright, so that's the first difference. Let's look at the second difference. 3 to 9, add 6, 9 to 15, add 6, 15 to 21, add 6. Since the second difference was all the same here, this is going to be considered a quadratic function. For number 14, same thing. Negative 1 to 1, we have to add 2. 1 to 15, add 14. 15 to 53, what is that? Add 38. Yeah, looks like 38. And then 53 to 27, add, here, hold on. Let's see what that would be. 127 minus 53, so we have to add 74. Alright, so that's the first difference. Now let's check the second one. 2 to 14, add 12. 14 to 28, add 24. 38 to 74, add 36. Alright, so for the third difference, we get plus 12, plus 12. So this would be considered cubic. And then for number 15, this is just going by plus 2's. So this would be linear. Alright, so differences will help you figure out if it's quadratic, cubic, or linear. If you want to see if it's a cube root, you just have to kind of look at it. So for example, something that's cube root would, for example, be like 27 and 3, 8, 2, 1, 1, 0, 0, negative 1, negative 1, negative 8, negative 2, negative 7, negative 3. So this would be considered cube root. So with cube root, there's not really a way to tell what it is using differences. You just kind of got to recognize if it's a cube root. Alright, so now let's go to the solving. Alright, 16, the cube root's isolated, so let's go ahead and cube both sides. We got x plus 5 equals 64. Minus 5, x equals 59. Right. 17 minus 3, we got 4 cubed root of x minus 2 equals 8. Divide by 4. And then let's go ahead and cube both sides. We get x minus 2 equals 8, and then add the 2, x equals 10. Alright, so remember, you're cubing, not squaring. Right, now number 18, we have this minus 4, so let's go ahead and add 4 first. Alright, so we get 10 on the right side. Now let's go ahead and cube both sides. We get x minus 7 equals 1,000. Add 7, x equals 1,007. Alright, then for number 19, we're going to go ahead and subtract the 3. Then let's divide the negative 2. Alright, when you divide negative 14 with negative 2, you get a positive 7. Now let's get rid of this cubed root by cubing both sides. So we have x plus 9 equals 343. And then just subtract 9. We get x equals 334. So now that's solving for x. Now let's go and find the inverses. So let's find the inverse of the following cubic and cube root functions. Show all work. Alright, so when you're trying to find the inverse, or you hear the word inverse, you should think of switching x and y. So we have x equals 6x cubed, 6y cubed. Alright, so let's subtract the 1. We have x minus 1 equals 6y cubed. Then divide the 6. Then let's go ahead and cube root both sides. Alright, so our inverse here is the cubed root of x minus 1 over 6. Guys, also when you cube root something, cube root a fraction, just always check to see if you can reduce the numerator, the denominator. So here x minus 1 can't cube root that. Same thing with the 6, so just leave it the way it is. Alright, then 21. This is one that's important to study. Make sure you understand this one. Alright, let's go ahead and switch the x and y. I'm going to add 3 to both sides. We're going to divide the 8. Alright, so now to get rid of this cube, let's cube root both sides. Guys, and then like we said earlier, when you cube root a fraction, check the numerator, check the denominator. So you can technically cube root each one on its own. So let me do that up here. And if you read it this way, obviously cube root of x plus 3, you can't do anything to it, so it would just stay the same. But cube root of 8, that turns into a 2. Alright, so we're going to use this down here. So we have the cube root of x plus 3 over 2 equals y plus 5. On the right, again, remember on the right side, the cube and the cube root cancel each other out. So then the last thing we have to do is just subtract 5. So my inverse here ends up being the cube root of x plus 3 over 2, because the 8 cube rooted, with minus 5 at the end. Alright, so that's 21. Again, if I were you, I would replay this one and try it on your own, see if you can get it. Alright, so then 22, same thing. Let's go ahead and switch the x and y. I'm going to subtract the 8. And then cube both sides. And last step, just add the 6. So your inverse here ends up being x minus 8 cubed plus 6. You guys also remember something with inverses. Here on 22, the original one had a minus 6 on the inside. For the inverse, we had a 6 on the outside, and it was a plus. Original had a plus 8 on the outside, so for the inverse, there should be a minus 8 on the inside, which that happens. Same thing on this one. We had a plus 5 on the inside. For the inverse, we had a minus 5 on the outside, minus 3 on the outside, plus 3 on the inside. Also, same thing here. Plus 1 on the outside, minus 1 on the inside. Right, then for 23, we have x equals 4 cube root of y plus 7. We're going to go ahead and divide the 4. So we have x over 4 equals the cube root of y plus 7. Alright, so we divided by 4, or switch the x and y, then divided by 4, and then we're going to go ahead and cube both sides. And then minus 7. Alright, so your answer could be left as x over 4 cubed minus 7. Or, again, this is a fraction. You could cube the numerator, cube the denominator. If I cube the x, we get x cubed. If I cube the 4, we get 64. And then minus 7. All right, so either one works for this one. But for the cube root one, like the one we did before on number 21, make sure you cube root that 8. Alright, so y'all's might look a little bit different than mine, so if yours is different, just follow along with this one, then I'll get to the one that's on your packet. Alright, so 24 just says graph the function and its inverse, find the inverse using the table and graph. Or find the inverse using the table, the graph, and algebraically state the point of inflection for each function. Alright, so right now I know this has a vertex or point of inflection of -5, -3. Alright, so let's just use the calculator and let's see how let's get the points and see how this is going to look like. Alright, so I'm going to take a couple points above and below the vertex, so -5, -3, we have -6, -4, -7, -11, we have -4, -2, -3, +5. Because if you're not too sure on how to put these together, just look at your graph and just follow the same pattern right here. So I just use the graph in the calculator to help me guide me on making the graph. Alright, so now for the inverse, again, we know all we have to do is just switch the x and y. Alright, so let's switch the x and y. So now we have -11, -7, -4, -6, -3, -5, -2, -4, 5, -3. Alright, so the point of inflection, on the last one was -5, -3. So on this one it should be -3, -5. Alright, so let's take these points and put them on there. So we have -4, -6, -3, -5, -2, -4, 5, -3. There we can see the inverse. You could also tell their inverses because they reflect over the line y = x. And also the x and y's are switched. Also, alright, so now let's find this function algebraically. It should be a cube root function. Again, you can tell by looking at the graph, it's going this way. Alright, so we're going to take the original one and flip the x and y. Alright, so now let's add 3. Cube root both sides. So we have the cube root of x plus 3 equals y plus 5. And then subtract 5. And so our inverse here algebraically is the cube root of x plus 3 minus 5. Which makes sense. This would have a point of inflection at -3, -5, which is what we had up here. Right, now for the application problems, this should be on everyone's packet. So it says the formula D equals the cube root of 4w over 0.02847 relates the average diameter of a cultured pearl in millimeters to its weight in carats. What is the average diameter of the pearl whose weight is 3 carats? Alright, so we're given the weight, it's 3 carats. We're trying to find the average diameter. Alright, so let's set up the equation with what we have. So we don't know the diameter, but we have the cube root of 4 times 3, which is the weight, divided by 0.02847. 2847. Alright, so let's just plug this right into the calculator. We're trying to find diameter, so we don't have to move anything. It's already set equal to D, so just plug this right into the calculator. Remember, math 4 to get the cube root. Do that again, math 4. Alright, so we got 4 times 3 for the numerator, and on the bottom, 0.02847. And we get 7.50. Here, 7.50. Alright, so now B says, what is the weight of the pearl with an average diameter of 6? So this time we know diameter at 6, and then we're trying to find the weight. Alright, so let's try to get W by itself. Let's go ahead and cube both sides. Alright, 6 cubed is 216. Alright, we're trying to solve for W, so let's multiply this bottom part to both sides. So divided by 0.028475, so we have to multiply that. So let's see what we get. So 0.02847 times 216. We get 6.15. And then let's divide that by 4. And then we'll get the weight. Alright, so the weight in carats would be 6.14 or 1.15 divided by 4. We get about 1.54 or 1.5. So about 1.54 carats. Alright, so then let's do the other ones that we skipped earlier. So we skipped composition. Alright, so let's look at the composition ones. Alright, so for composition, we have to prove f of g of x, g of f of x equal x. Alright, so let's start off with f of g of x. Alright, so that means g is going into f. So we got x cubed. Instead of x, we're going to put the cubed root of x minus 4. And that's being cubed plus 4. Alright, so g went in for x. Alright, so here the cube root and the cube would cancel each other out. We get x minus 4 plus 4. Minus 4 plus 4 just goes to 0, and we're left with x. So now we got to check the other scenario, g of f of x. Alright, so f is now going into this. So we have the cube root of x, but we're using x cubed plus 4, then we got that minus 4. Alright, so be careful when you write these out. Alright, first thing that would cancel would be the 4 minus 4. We're left with the cube root of x cubed. The cube root and cube cancel each other out, then we're just left with the x. So yes, this would be an inverse, or they would be inverses of each other. Same thing on 25. G is going into f. That would be the cube root of x minus 6 cubed with plus 6 on the inside. So all this was going in for this x. The cube root and the cube would be the first things that would go away. We get x minus 6 plus 6. 6 is cancel. We just get an x. So that works. Now let's test it the other way. F is going into g now. So parentheses, instead of x, we're going to put the cube root of x plus 6. We got minus 6 cubed. First thing that goes away here is the 6's. we got the cube root of x being cubed, which just leaves you with x. So both of those work. Alright, so now for the last one, 26. This is on volume. Alright, so we're given the volume of a sphere. We're given the formula. This says that the volume of a sphere is 1013 pi centimeters cubed. What is the radius of the sphere? So we're trying to find r. And we're given the volume. Alright, so we got 1013 pi over 4/3 pi r cubed. Here guys, both sides have a pi, so let's just go ahead and divide the pi to both sides. When we do that, we're just left with 1013 equals 4/3 r cubed. Alright, so now let's take the reciprocal of this and multiply it to both sides. So let's get rid of that 4/3 by multiplying by 3/4. Alright, so let's see what that comes out to be. Alright, we get 759.75. Now let's cube root that. Math for. Alright, so we just cube rooted that. And we get that the radius is going to be 9.12. And this is in centimeters. Alright, so that is the end of the review video. If you have any questions, make sure you let your teacher know. And also don't forget to like, share, and subscribe, and share this with your other Algebra 2 buddies. Alright, you have a good one.